Today's live session will focus on few multiple choice questions, previous NBDE questions from the topic Physiology. A very good evening all of you. So I hope you have celebrated your Diwali well, and we'll start with our questions now. I hope you guys are ready. Let me know if you have any streaming issues, or let me know if you want me to raise my voice. Right? So we'll start with our first question regarding the composition of intracellular and extracellular fluid. Extracellular fluid comprises what amount of total body water? Option A 25%, option B 33%, option C 50%, option D 66%, option E 75%. So extracellular fluid comprises what amount of total body water? So as you know, we have intracellular component as well as extracellular component. Intracellular component almost constitutes 2/3 of total body water, whereas extracellular component constitutes 1/3 of total body water. And in extracellular components, we have 3/4 of interstitial fluid and 1/4 of plasma. So we have this division, right, which is very, very important. So if you look into this particular table, the schematic representation of total body water volume, you can see almost 2/3 is intracellular fluid or water within the cells, whereas 1/3 is extracellular fluid. In this 1/3, again 3/4 or around 80% is interstitial fluid, and around 1/4 is plasma volume, right? So this division is very important. Make sure you enter and memorize these percentage distributions, right? So if you come back to the question, extracellular fluid comprises what amount of total body water? As we discussed, it's around 1/3, right? So which correlates with option? Yeah, it's option B, 33%, 1/3. I'll just show you the image here in my mobile so that it will be much more clear. So you can see of the total body water, 2/3 is intracellular and 1/3 is around 15 liters. In this case, it is extracellular. And extracellular 80%, that is 3/4 will be interstitial fluid, and 1/4 will be plasma volume, right? So just memorize these values, it will be helpful for you, irrespective of the total body water content. If you remember these proportions, 2/3, 1/3, 3/4 or 1/4, if at all a question is asked based on a specific value, you can calculate and mark the appropriate answer, right? So option B, 33% is right answer. Fine. Okay, now let's move on to the next question. Which of the following types of blood vessels is responsible for greatest proportion of vascular resistance? Often we have confusion in this particular concept. So to clarify that, I will put an image explaining the same. So coming to the question, which of the following types of blood vessels is responsible for greatest proportion of vascular resistance? Is it option A, arteries, option B, arterioles, option C, capillaries, option D, venules, option E, veins? So which among the following is more appropriate, and why? And why? Because once you know why, you need not worry about remembering things. It will be easy for you to simply understand the concept rather than memorizing it, right? Yes, arterioles is right answer. Greatest surface area. It also contributes to greatest amount of peripheral or systemic vascular resistance. And studies have shown that there is almost 50% drop in blood pressure when blood flows from arteries to arterioles, which shows that arterioles are contributing greatest proportion to vascular resistance. And for information, vascular resistance is nothing but the amount of resistance that is exerted against the flow of blood, which has to be overcome so that the blood will be moving in the circulation. So that's vascular resistance. So systemic vascular resistance or peripheral vascular resistance, greatest contribution to this particular parameter is done by arterioles. And if you look into the following image, I'll also try to zoom in. At the same time, you can see the same in my mobile. Yes, Akriti. So as you can see, drop in blood pressure from arteries to arterioles. You can see this specific area. There is almost 50%. See, it's almost 80 here. It's becoming 40 here. So in the area of arterioles, you can see greatest drop in blood pressure, around 50%. So based on this graph, it's evident that arterioles are the greatest contributors to peripheral vascular resistance or systemic vascular resistance. It can be the size of the lumen and the surface area, various factors which play an important role in contributing to this peripheral or systemic vascular resistance. It's from an article, it's not from a book, it's from an article, right? Yes, option B is right answer. Wonderful. So most of you got the concept right. Now let's move to the next one pertaining to Starling's hypothesis, Starling's forces. Let's see how it goes. Which of the following pressure changes will result in edema? Option A, decreased capillary hydrostatic pressure. Option B, decreased interstitial oncotic pressure. Option C, decreased capillary oncotic pressure. Option D, increased interstitial hydrostatic pressure. Option E, all of the above. So among the given options, which of the following would lead to edema? As you know, edema is nothing but accumulation of fluid in interstitial tissue or movement of fluid from the vascular component to extravascular component. Take for example patients with nephrotic syndrome. There is loss of proteins. Let me not explain the mechanism. First, let me know which option is more appropriate in this question. A, C, D. Options A, C, D are covered in your comments. Only B remains. Remember, hydrostatic pressure is a kind of push force. Oncotic pressure is a kind of pull force. Hydrostatic pressure is contributed by fluid which moves in and out, whereas oncotic pressure is contributed by large molecules, most importantly proteins. So hydrostatic pressure is a kind of push force. Oncotic pressure is a kind of pull force. So based on that, you can answer this question. We'll go through each option. Decreased capillary hydrostatic pressure. So decreased push force, as a result, more amount of fluid comes inside vasculature. You can rule out option A. Option B, decreased interstitial oncotic pressure. So interstitial pressure, oncotic pressure is less. As a result, more fluid will be again going into the vascular component, because as we discussed, oncotic pressure is nothing but a pull force. Since pull force in interstitial tissue is less, so more fluid will be drifting towards vascular component. If you look at option D, increased interstitial hydrostatic pressure. Increased interstitial hydrostatic pressure would lead to again a kind of push force from the interstitial fluid towards the vascular component, right? Even that can be ruled out. So the only option that seems to be suitable for or a condition favorable for edema is option E, decreased capillary oncotic pressure. So capillary oncotic pressure is a vascular component. So within the vasculature there is decreased pull force. As a result, most of the fluid is drifting from vascular component towards interstitial component or interstitial fluid or extravascular fluid. So it's very simple if you remember it this way. Hydrostatic pressure is a kind of push force, whereas oncotic pressure is a kind of pull force. The concept which I have explained here can be easily visualized from this particular image. So we have a vascular component and extravascular component. In vascular component, again we have hydrostatic pressure, oncotic pressure. Extravascular, again we have hydrostatic pressure and oncotic pressure. Now try correlating with these options, it will be much more clear for you. So let's come back again. So increased capillary hydrostatic pressure would lead to movement of fluid extravascular as given here. Increased plasma oncotic pressure would lead to more pull force, so fluid moves from extravascular towards the vascular component as indicated by the arrow. Increased interstitial hydrostatic pressure would lead to pushing of the fluid from extravascular to intravascular, and increased interstitial oncotic colloid pressure would obviously lead to more pulling, thereby movement of fluid from the vascular component to extravascular component. Right? The same image I am trying to project even through my mobile so that it will be easy for you to note down. So just note down this simple schematic diagram. It will be easy for you to understand the concept. Starlings forces. Just remember, hydrostatic pressure is a push force, whereas oncotic pressure is a pull force. Hydrostatic pressure, as the name itself indicates, is created by fluid, whereas oncotic pressure is created by larger molecules, most importantly plasma proteins or protein component. I hope it's clear. So option C seems to be favorable for edema. That is nothing but movement of fluid from vascular component to extravascular component. I hope it's clear. Okay. It might take time, but once you get the concept right, there is no going back again. Fine? So penultimate question. Let's see how many of you are going to answer it right. Carbon dioxide is carried in blood as option A, dissolved carbon dioxide, bicarbonate, carbaminohemoglobin, both options A and B, all of the above. Carbon dioxide is carried in blood in which of the following means or forms? In fact, we have discussed the same in our E-classes as well. You can find the video, transportation of carbon dioxide, in Physiology section. So how is carbon dioxide transported in blood? Dissolved carbon dioxide, bicarbonate, carbaminohemoglobin, A and B, all of the above. Remember, most of the carbon dioxide is transported either in plasma or in erythrocytes in form of bicarbonates, as you can see here, mostly in the form of bicarbonates. And a very minor or small quantity is dissolved, physical dissolution of gas, and is transported in the form of dissolved carbon dioxide. And around 20% of carbon dioxide is transported in the form of carbaminohemoglobin, which contains an amino group. So, among the given options, A, B and C are right. So, all of the above, option E is right answer. So, majority in the form of bicarbonate, a very small quantity in form of dissolved carbon dioxide, physical dissolution of gas in blood, and around 20% in form of carbaminohemoglobin, presence of an amino group, right? So, all of the above is right answer. I haven't put option D there. As I said, these are previous NBDE questions. These are the questions. I'm just presenting you the questions. Fine. Now, final question. The immersion. It's again the concept. So this entire session is all about getting the concept right. The immersion of cells in hypotonic solution will result in which of the following? Option A, cellular swelling. Option B, cellular shrinkage. Option C, no change. Option D, none of the above. So when you place cells in hypotonic solution, what would be the consequence? It's all about the concept called osmosis, and I'm sure you are very much thorough with this concept, right from your high school and +1 or +2. majority of you seem to be in soup. Is it shrinkage or cellular swelling? First of all, what is osmosis? So as you can see in this image, we have a chamber, a semi-permeable membrane. On the left side, you can see hypotonic solution. Tonicity depends upon the presence of solute. You can see less number of solute, less amount of solute in this solvent. But on the right side, you can see more amount of solute. So comparatively, the left one is hypotonic, the right one is hypertonic solution. Osmosis is nothing but movement of fluid from a solution of lower solute content to a solution of higher solute content. So you can see the direction of osmosis from left towards right. So this is osmosis, right? The question now is, when you place a cell in hypotonic solution, what would be the consequence? Assume that this is your cell, the right side is your cell, the left side is your hypotonic solution. So what would be the consequence? Is it swelling or shrinkage? Yes, Prerna. Osmosis is shift of fluid from low concentration to high concentration. Exactly, obviously it has to be swelling. There will be swelling. So when a cell is placed in hypotonic solution, it would result in cellular swelling, option A. Do not focus on remembering the right answer, just get your concept right. Everything will be like a cakewalk. Good. Yes. So I hope it's clear, right? Now, so before we conclude, identify the place based on the following GPS coordinates. It will be interesting. Identify the place based on the following GPS coordinates: 13.4125 degrees north, 103.8670 degrees east. No, it's definitely not Manali or New Delhi. Google doesn't lie, right? It can't be one place for me and one place for you and the other place for another person. It will be the same for everyone. No, it's not Denmark. Yes, Karishma, I have explained in detail about oncotic pressure and hydrostatic pressure. Just go through the video once again along with the image. And if you have any query, get back to me through mail. No, it's not Pakistan. Not Nigeria. Suresh seems to be very close. No, it's not Pakistan, it's not Karachi. But Suresh seems to be very close. Okay, since Suresh has mentioned, so which location in Cambodia? Deepa Avasti water discovery. Yes, it's definitely somewhere on earth. But where is that somewhere? It's like you attend entrance exam, you come across one question and you say answer might be among the 4 options, so let me not answer it because answer is somewhere there. Okay, Suresh, Google seems to be working more accurate and fast comparatively. Yes, Angkor Wat. Angkor, A-N-G-K-O-R, Angkor Wat. It's the largest temple. Previously it was a Hindu temple, but by the end of the 12th century, it was converted to a Buddhist temple. So it is considered to be the largest temple in the world. Angkor Wat in Cambodia. Okay, well done. Right, I hope it's clear. And I think I've given you the summary of all concepts, and you have any further queries, you can always drop a mail at proctobidentist@gmail.com. You can also check out our website pdpdacademy.com. right? Yes, Kiran. Austin Queensbury, I haven't heard of that place yet. Yes, it is in Cambodia, Angkor Wat. Fine, I hope you enjoyed today's session. Again, see you tomorrow in another live session. We'll come back with another live session. Fine? Just keep the momentum going. Just give your best. It's easy to say, but only a person who is giving their best will know its true value. It's all about giving your best no matter what you're doing and where you are. Just give your best and you will definitely receive the best. Love you all. Good night. Yeah, we'll update you in our Google group as well as WhatsApp update group. Just join our groups, you'll get an update at least few hours prior when we have a live session. Yes, Suresh, we'll definitely have more live sessions. Yes, Speed Jada, I can understand Hindi, but I cannot fluently speak Hindi. Rashid Khan, love you too, Rashid Khan. Thank you. I mean, for any links, you can drop email at talktobidentist@gmail.com, right? Srish, I hope you got the clarity of the images which we have presented today, right? You asked me to zoom actually. Even though if I zoom, will not get so much of clarity, so I try to project my mobile itself. I hope it's clear, right? You need any further assistance, get back through me. Yes, Peer Chada, glad to hear that. Coffee session is over. Coffee is happy and excited because session is done. Now we will have time for play. Okay, good night. Toffee, say good night. Good night. Good night, everyone. Yeah, bye.